Hello, and welcome to 5 Minute Math. Today we are looking at the 8th grade STAAR Test 2025. If you would like to follow along, I've created a custom statewide item analysis report that you can access using the tiny URL or the QR code on the screen. If you want to jump ahead to any particular item, you can do so by using the timestamps you see or by scrolling up and using the bookmarks that are available at the bottom of the video. For our first problem, we are looking at 8.4b, slope as unit rate. And we have a student here that is reading 24 books in 15 weeks. Now, if you'll notice, we've got books and we've got weeks here. And so books is going to be our y value variable or our dependent variable, and weeks is going to be our x variable or independent variable. So if I want to put this particular relationship into an xy coordinate, pair, I need to go ahead and flip those because the weeks is going to be our x. Now let's just see if we can find that. So we need an x of 15 right there and a y of 24. Now that is actually on that point, but that's just saying that the student read the exact same amount, 24, every single week, and that doesn't make sense. The slope would be increasing because every week they're reading more and more and more. If we're looking at B, we're looking at 15 and 24. All right, so that looks like that at least goes through that point. If we're looking at C, do not see that point. What we do see is probably that point reversed. We do see the 2415. And then it goes to 2415, but this is just strange. The time stays the same, but the number of books increases. So these two don't make any sense. This is just reversed, right? This is 2415. So our answer here is going to be B. And they always give us some easier ones at the beginning of the test, and this is no different. We had 77% of our students choose this, which definitely made this a freebie. We had 13% choose C, so they just reversed it to where's X value of 24, Y value of 15, 5, and 4. Now, we still had 9% of our students just guessing random stuff, so that's never good. But we at least had 90% of our students trying to figure out 24 and 15, 77% get it correct. This was the first easiest item on the test. So everyone felt good after this one, but it all gets more difficult after this. For our second problem, we are looking at calculating interest. This is 8.12d. Sometimes we need to work with simple interest, sometimes compound interest, sometimes both. In this case, it looks like we're dealing with just simple interest. All right, so we have $4,500 in investment account, 4% interest for 5 years. We need to complete this sentence. It's a 2-point problem. We need to figure out, first off, how much the interest will have earned, and what's the new total balance. And the reason they have to ask us that is because if we look at our reference materials and we look at down at the very bottom, we see our simple interest. That formula actually does not give us the new balance. We actually get the new balance when we're using the compound interest formula, but this one is just I equals PRT. So that means we are going to calculate for our interest. We need to know what each of these letters stand for by calculating our principal. In this case, that's the initial amount, $4,500, times the rate. There's your 4%. Now we need to turn that into a decimal. So 4% is 4 per, anything percent is per 100, over 100. So 4 hundredths turns into 0.04 because that's 4 hundredths. And then we have our time, and that's 5 years. All right, so we're going to multiply all that. We're going to get our interest. Let's get our calculator out. And let's do that. 4,500 times 0.04 times 5 years. All right, 900. All right, so we are going to earn $900 of interest. That's not bad for 5 years. Not bad at all. And what's the new balance? Well, we have to take that 900, then add it back to the principal, because remember, you started with 4,500. Let's go and add 4,500, and you're going to get 5,400. All right, so those are our two answers. We had $900 in interest, $5,400 as our new balance. And this is a 2-point problem. And so in order to get both points, you need to get both correct. Obviously, we had 66% of our students get both. We had 18% get 1 point. So if we take half of that 1 point and put it with the 2 points, we can get 75% overall percent complete, just because it's kind of hard to calculate that percent complete on a multi-point problem. So we just take half of the 1 point, add it to the 2 points, say that's our accuracy for this problem, 75%. And 16 walked away with 0 points. This was our second easiest item. So our first problem was our first easiest. Our second problem was our second easiest. So it still only gets more difficult from here. Number 3, we are looking at identifying functions. And so we need to remember, what does it mean for a y to have a function of x? It means that for every x, it goes to just one y. You can't have the same x going to multiple y's. If so, now we are not a function. Each x goes to one y. So let's see which of these actually matches that rule. Look at your x's first. 5, 7, 9, 11. Well, that's fine. I don't have any x's repeating, which means it doesn't matter. What you can have is you can have multiple x's going to the same y. That's fine. That's fine. What we can't have is this right up here. That is what we can't have. So since all the x's are different, that's going to be it. Just take a look. I've got 5 and 5. 5 goes to 13, and 5 also goes to 17. One x, multiple y's, not going to work. Here on C, I've got 8 and 8. 8 goes to 22, 8 also goes to 9. One x cannot go to multiple y's. And then here I've got 9 and 9. 9 goes to 15, 9 goes to 17. Can't get it. So our answer here is A. And we had 73% of our students get this correct. So this was our third easiest item on the test. And so our first was our first easiest. Second problem was our second easiest. Third was our third easiest. It will not continue like this. In fact, it is going to end now. Number 4. We need to find a true inequality, and I've got some percents, and I've got a radical. So let's get our calculator out. And let's see. 10 thirds. All right, so I'm going to make these decimals, and let's put them on a number line here, just to kind of help organize what I'm doing. And so I'm going to say that I've got 10 thirds. I'm going to make everything a decimal, so let's just do this. So I will say that's my 0. This is going to be my 10 thirds, or 3.3 repeating. And this is supposed to be less than square root of 10. So let's do the square root. Hit the second button, hit the x squared button. All right, now take a look at this. Here's so this is 10 thirds. This is square root of 10, because this is 3.16 approximately. It keeps going on and on and on. That is incorrect, because the 10 thirds is actually greater. So that's not true. Let's look at negatives. Okay, so, and if we could do decimals again if we need to. All right, let's get 1/8. All right, so here's my 0. All right, so I'm going to have negative 1/8, which is negative 0.125. That is supposed to be less than negative 1/3. So 1/3, 0.33333. But take a look at this. The negative 1/3 is actually farther away from 0 because it's negative 0.333. 333 is greater than 125. But since we're dealing with negatives, that means it has a greater absolute value, which means it's farther away from 0, which means this is actually greater than, because it's closer to 0, right? Greater than goes this way, less than goes this way. So it gets flipped when we're dealing with negatives. So 150% is greater than 2. I'm going to just put 2 right here. 150% is, remember, 150% is always per 100. You can always divide by 100. You're going to get 1.5. Is 1.5 greater than 2? No, it's less than 2. All right, so now let's deal with these last negatives, and it's got to be this. All right, so they're both in decimals, so we don't need to do anything with this calculator. So I'm going to say 0.07, and I'm going to add a 0 here so we can take a look at that. So if I'm 7 hundredths away from 0, and I'm 70 hundredths, which is the same as 7 tenths, away from 0, then we're going to say that this 70 hundredths is less than the 7 hundredths, or we can say that the 7 hundredths is actually greater than, this is going to be correct, at 7 tenths, because it's closer to 0. It's because it's negative. Negative flips everything on its head. So this D is correct, but as I was saying earlier, this was definitely on the more challenging side. And so we had 41% of our students choose this one, whereas we had 32%. It's the negatives. Really messed us up here. 32% chose B. We had 15 and 12. And so it's dealing with negatives. You have to look at the absolute value, right? And so when you have a larger negative, that means it's actually less than a smaller negative because it's farther away from 0. That's what makes it less than. So this was definitely challenging. And our biggest work is still with negatives. Things that we are introduced to in 6th grade are still troubling us in 8th grade. And this was tied for our 9th most difficult item on the test. And so if 8th grade teachers, let's continue to do work with negatives, have them draw number lines, and think about the absolute value. Number 5, we are looking at linear relationships. This is 8.5C. I'm going to drag this down here. And so what we have is a linear relationship, and we need to find the slope and the y-intercept. Should be fairly simple. First off, the y-intercept. I mean, that should be a no-brainer. It's a visual recognition. Where does the line cross the y-axis? That's why it's called the y-intercept. Okay? So that is going to be at 1. So I see a y-intercept of 1, y-intercept of 1. Get those two out of here. Students should have immediately been able to get rid of C and D, which for the most part they did. We're really stuck between A and B. So it's going down from left to right, which means it's negative, and they're both negative. Okay, so you can't eliminate one if they had a positive. So let's find the slope. We can either just visually draw the rise over run, or we can use our formula here. So slope of a line, and it's going to be this right here. So the problem sometimes with finding this is sometimes you have to try to find 2 points that work. Well, they gave you 2 points that work. So let's label this x1 and y1. If you wanted to flip those, you would still get the exact same answer. x2 and y2. As long as we label them, we can keep them straight. We're good to go. So y2 is 3 minus y1, negative 1. x2 is negative 6 minus, and then 6 is x1. So that's going to be 3 plus 1 over negative 12. So that's going to be 4 over negative 12, which equals my negative 1/3. And so here's my answer B. We also could have just calculated it like this. We could have done rise over run. And so it goes down 1 over 1, 2, 3. So negative 1/3. We could have gotten it that way, as long as you do the correct order. Up or down, rise over run, left to right. All right, and so this is going to be our answer B. Now, how did we do on this? A little bit better, 61%, and 22% chose A. So 83% were at least able to get the correct y-intercept. We had 8 and 8 down here. This was definitely on the easier side, tied for our 7th easiest item on the test. We wanted students to be able to use just visual cues, this rise over run, and also the slope formula to find the slope. For number 6, we are looking at transformations on the coordinate plane. We need to find the rule that describes its transformation. It looks like, now it just says transformation. So it looks like it's a rigid transformation, and honestly, it looks like a translation. If we're just going to verify visually what we think is happening, I'm thinking it's translation. So when we translate, it's going to be adding or subtracting. We're just sliding the x and y values. We're not multiplying. If we multiply, that's a dilation. Okay? And so we don't have any multiplication here, so we don't have to worry about that. But if you did see a multiplication, we can get rid of that because that's a dilation. That's where we change the size, but we keep it similar. All right, so let's just take one value here. I'm going to go from t to t prime. So you start with t, and they give you the order here, to t prime. All right, so what is my t? My t is 4, 4. And now my t prime is 10, 2. Look at my x values. How do I go from 4 to 10? Well, I can go from 4 to 10 by adding 6. And how can I go from my y value of 4 to 2? Looks like I can subtract 2. So it looks like it might be an x plus 6 and a y minus 2. But let's verify with another pair. Let's do the u's. U and u prime. So what is my u? 8 and 4. I'm going to do it like this, since I already think I know what it is. Let me get my u prime, which is 14 and 2. U prime, and let me just add it like this. Can I do an x plus 6? 8 plus 6 makes 14, yes. Can I get a 4 minus 2? Yeah, 4 minus 2 equals 2. All right, so it's x plus 6, y minus 2. So our answer here is C. And we actually did fairly well on this one. 67% of our students got this correct. You notice that we had 14% choose B. That's our second most chosen answer. And we just flipped, right? We flipped the positive and the negative, the add and subtract, and then 7% chose that. And so this was actually moving from the primes back to the original. And so we need to make sure that our students know that we're going from the original to the primes, not reverse, because this x minus 6, y plus 2 would actually work if you started from the prime and moved back to the original. And this was our 5th easiest item on the test. Number 7, we are representing linear proportional relationships. This is 8.5a, and it's graphing. So we're just going to have to put some points on there and watch for the line to appear, because that's how this graphing works. All right, so we need to plot 2 points that represent a proportional relationship in which y is 7, x is 3. Okay, I can do that. Y is 7, x is 3. All right, so I can do that. Y 7, x is 3. How am I supposed to graph this if they only give me 1 point? Well, they actually give us a clue for the second point, but it's a vocabulary word. Look at what type of relationship they said. They said it was a proportional relationship. So if it's proportional relationship, that means it does not go across the y-axis at any point other than the origin. It always goes through 0, 0. There's no y-intercept. So my second point is going to be here, but they didn't tell us 0, 0. They didn't tell us the origin. The word proportional is a key word for it goes through the origin. So if I get my second point on the origin, that's it. Now that was tricky because a lot of kids got that, that coordinate pair of 3, 7, and then they didn't know what to do. In fact, only 33% of our students got this correct. It's just a 1-point problem. This was definitely hard. This was actually the fifth hardest item on the test, and it comes down to vocabulary. This was easy, but understanding, and we talk about proportional and non-proportional relationships, but we need to make sure our students know that that means that we can plot through the origin. For number 8, we are looking at trend line. This is 8.5b. And we have the scatter plot here. We've got some data. We're trying to find what's going to happen when we get that to $1,000 spent on advertising. So let me kind of move this down here. All right, so what we want to do is we want to see if we can find a way to connect a line showing this linear relationship here. And we want to get it to 1,000. So that's going to be way over here. And so when we're making this trend line, what we want to do is we want to get about half of the dots above the line, half of the dots below the line. So if I'm looking at 1, 2, 3, 4, 5, if those 5 could be up, 1, 2, 3, 4, 5, and the 5 that are circled can be below, what I want to do is I'm going to connect it to where I'm kind of going like this. And what I'm trying to do is those 5 that I just circled, I want to get those at or above the line. All right, so that's going to be close enough. I've got 1, 2, 3, 4, 5 above the line, and then 1, 2, 3, 4, 5 below or on the line. And so that's about as close as we can get with this trend line here. And so we're looking for 1,000. And so if we come up here, you see we are between 12 and 1350. We're a little bit above it. So call it about 13,000, maybe 12,750, but 13,000 is going to be close enough. And so that is going to be our answer C. Now, just to verify, let's plot some of these other points, right? So 15,000 is going to be way up here, way too high. 11,000 is going to be right around there, and then 8,000 is going to be down, maybe right there, maybe up a little bit. But as you can see, that 13,000 is going to be our best shot. And so while it might seem like a difficult strategy, that is going to help us if we actually try to draw that line using that connect line feature that we have on Cambium. Now, 54% of our students were able to get this. 30% of our students chose B, which was that next closest, and it's just too low. They underestimated the slope, unfortunately. Then we had 8% choose A, 7% choose B. That's just pure random guessing. So this was about middle of the road, but it ended up being slightly on the easier side. In fact, this was the 18th easiest item on the test. So not super difficult, but it's hard to eyeball it. I highly suggest drawing that line using this connect line feature that's available when we have the graph draw feature up. And so let's go ahead and get that. There we go. All right, number 9, you see that we've got just an equation editor that we have to put the answer in. This is surface area, 8.7b. And so what we want to do here is we want to calculate the surface area, and there's no picture, so let's add one. A visual is always going to help. The lateral surface area of a triangular prism. All right, so I'm going to draw a triangular prism, at least some type of uh, version of that right here. Go like that. So I'm going to try to draw my same triangle back there. All right, so I've got my two faces and I'm looking for the lateral surface area. So what that's going to be is, like, let's extend this down a little bit. Make it look like that. Okay. So what we want to do is we want to get the three rectangles. The one right there, one in the back, and then the bottom. We want to get those three rectangles that are connecting the two bases. That's what we're dealing with the lateral surface area. But we don't have to do that by hand. Let's look at our reference material, see what we have here. And we've got surface area. This is a triangular prism, and it's lateral. So S equals PH. That is going to be our formula. So that lateral surface area is perimeter times the height. Now, when we're talking perimeter, we need to know the perimeter of what? Well, it's the perimeter of the base. Okay, so we didn't put any dimensions on here. We know that that lateral surface area is 252 feet. Okay, so we can actually put that in for that 252 square feet. So if they give us the lateral surface area, that means they're looking for something else. They're either looking for the perimeter or the height. In this case, we're looking for the height. Well, what is the perimeter? It's a triangle. The side lengths are 6, 7, and 8. All right, so that perimeter is going to be 6 plus 7 plus 8, which means we're simply looking for that height. So what is 6 plus 7 plus 8? That equals my lateral surface area, 252. It's going to be 13. That's 21, 8. All right, so we just need to divide 252 by 21. Let's see what that is. 252 divided by 21, 12. All right, so what we did here is we divided both sides by 21, and we get our height of 12. So we're just going to type that in. Now, that was a little bit challenging. There was no visual, and they gave us the surface area, and they're looking for the height. Sometimes they'll give us the dimensions, and they want us to find the surface area. We only had 39% of our students get this correct, and 61% obviously did not get this correct. This was definitely challenging because we were looking for one of the dimensions rather than the complete surface area, and the lack of visual definitely helped raise the rigor. And if you weren't using this formula, these three numbers, the 6 and the 7, the 8, they don't mean anything unless you know that you're looking for this perimeter. So you have to connect the correct formula, the perimeter, to the problem to know, oh, that's just going to give me my three side lengths. That's going to be the perimeter. This was the eighth hardest item on the test. And so when we are working with this particular problem with our students, we definitely need to do it without visuals so that they can draw something to anchor themselves and look for height, give them the surface area. Give them the surface area and the height, and give them two of the three measurements of the perimeter if it happens to be a triangle. Things like that. Have them look for the smaller dimensions, not always looking for the surface area. For number 10, we are looking at one variable equations. This is 8.8c. And if we wanted to, we could guess and check here. We could take each of all four answers and substitute it in. But let's just solve it as if we didn't have that option. Right? It's good practice for us. So we want to isolate the variables. We want to get x on one side. We want to get our constants on the other. There's not really any issue with the left side. It's already negative 6x plus 8. So we've already got the x's together, the constants together. We do need to distribute out this 2 to the x and the negative 12. So 2 gets multiplied by x, so that just becomes 2x. We're going to keep our minus, and then 2 also gets multiplied by the 12, so that's going to become 24. So now I've got negative x plus 8 equals 2x plus 24 because I distributed this. Let's get our x's over on the right side just to keep everything positive. So I'm going to add 6x here, and I'm going to add 6x here so that we're doing the same things at both sides of the equations to keep it balanced. Negative 6x plus 6x is going to cancel out. That's going to get me 8x. So I have my 8 and I still have my negative 24. Now we're going to add 24. All right, and so that's going to cancel out there, and that's going to get me 32 equals 8x. Now we simply divide by 8 to get rid of that coefficient, and x equals 4. So we have our answer. Let's verify. Let's go ahead and plug this back in. So negative 6 times 4 plus 8 equals 2 times the quantity 4 minus 12. So that's negative 24 plus 8, and this is 2 times negative 8. So this is negative 16 equals negative 16. So that does check out. So we're good here. Our answer is 4. And we did decent on this one. We had 55% of our students get that correct. Now we had 20% choose B. That was our most chosen incorrect answer. And so how we get this B is if we set up this equation right here. So we copy everything down correctly on the left side, right? Negative 6x plus 8. And then you only distribute the 2 to that first term, to the x. And then if you just bring this negative 12, which that's the issue right there, right? It should be a negative 24. But if you just do a negative 12 because you forgot to distribute that 2, you're going to end up with that 2.5. And so this is one in which the standard is one variable equations, but it goes back to understanding the distributive property. That's what's going to keep some of our students from being successful. And overall, this was tied for our 16th easiest item on the test. So not super difficult, kind of middle of the road, slightly on the easier side. Number 11, we are looking at dilations and measurements. This is 8.10D, and as you can tell, this is going to be a multi-point problem. We have inline choice that we need to pull into both of these statements to make them true. All right, so we have two parallelograms that are similar. The dimensions of the larger parallelogram are 8.4 times the corresponding dimensions of the smaller parallelogram. Okay, so we're looking at the change in the area and the change in perimeter. Okay, well, if we don't know this just off the top of our head, what happens when we dilate a shape? What happens to the area? What happens to the perimeter? We can easily just figure this out raw by plugging in numbers. All right, so I'm going to make the small parallelogram. Let's just make it a square. Doesn't matter what it is. Let's make each side 1. Okay, so that's easy. So my area equals 1 and my perimeter equals 4. Now, if I want to do, I'm not going to necessarily draw it to scale, but let's pretend this is 8.4 times bigger. I chose 1 because now these dimensions are simply going to be 8.4. And if I just do 8.4 all the way across, I can calculate this with the use of the calculator, but it's going to be kind of easy. If you didn't choose 1, then you have to do some multiple things. So let's go ahead and get that calculator out. And let's do some calculations. Let's figure out, first off, 8.4 times 4. All right, so my perimeter is going to be, let's see, 33.6. 33.6. And then my area, it needs to be 8.4 times 8.4. 8.4 times itself, right? 8.4 squared. We could just do that. 70.56. Okay, so how many times larger is the area of the larger than the smaller? Well, you do it as a ratio. 70.56 over 1, because that's what the area is right there. So it ends up being 70.56. So what we need to remember is when you dilate a shape, the area is squared, right? Whatever that dilation scale factor is, you square it simply because you're multiplying it by itself, right? You're multiplying those two dimensions. Now, when we get to the perimeter, we still set up that proportion. The new one is 33.6, but we need to divide that by 4. So 33.6 divided by the old dimension of 4, and that's 8.4. And 8.4, well, that looks familiar because that's the actual scale factor. So you square the perimeter, or you square the area, but the perimeter is simply the scale factor because you're adding. You're not multiplying to find the perimeter. You are adding. I did 8.4 times 4, but really I could have just done 8.4 plus 8.4 plus 8.4 plus 8.4. So that's something we need to remember about when we are dilating shapes. The area gets squared by the scale factor. So let me just go ahead and put that right here. Scale factor, and I'll push this squared right over there. That might make a little bit more sense. You square the scale factor, and you just use the scale factor to figure out the perimeter. So this is a 2-point problem. Now, I figure this out, pretending like I didn't already know that, just by substituting in some basic shapes. A lot of our students didn't do that by evidence of the fact that only 12% of our students got both points. 44% of our students got 1 point or partial credit, and then 43% of our students got nothing. You put that partial credit up there with the full credit, and you're getting 34% correct on this item. Definitely difficult. In fact, this was tied for our sixth most difficult item on the test. So this, these are just random things to memorize. I would definitely have my students work this out by hand like I did, just because that's going to be a good backstop in case they can't remember that you square the scale factor when you dilate for looking for area, and you use the scale factor when you dilate looking for perimeter. Show them how they can work it out by hand to verify. Number 12, we are looking at identifying proportional and non-proportional functions. This is 8.58. And so this seems pretty easy, but it does get kind of tricky here. We are looking for a proportional relationship. If we don't know what this means, then we're already in a world of hurt because there's nothing about these uh, different answer choices that are going to clue us into what that word means. So we need to know that proportional relationship means it goes through the origin and it has no separate y-intercept other than the origin, right? So we would use y equals kx. That would be a proportional relationship. We're not going to use y equals mx plus b. So if we look at the very top for linear equations, its proportional relationship isn't direct variation as opposed to the slope-intercept form. So whether you want to think of it as the origin, whether you want to think of it as direct variation, we need to know that in order for this to make sense. All right, so when we're dealing with word problems in slope-intercept form, there's always a b value. There's always an initial value that you have to say, nope, that's not going to be proportional, right? And so we've got the key on a map indicates that half inch represents 12 miles. Could that be proportional? Well, think if you were to graph this out, right, you could say half inch equals 12 miles, all right? Would it make sense that 0 inches equals 0 miles? Yeah, that would make sense. So let's do that right there. As that's possibly the answer, but we got to verify that the rest of these aren't going to work. So using a coupon to purchase bottles of apple juice for $2.28 each reduces the total cost by $1. All right, so we have an additive relationship, right? Um, we've got -1, so that already tells me that we're going to have y equals mx plus b. We have some type of scale, right? So that's going to be the 228. It's going to be our cost per apple juice, and then we're subtracting 1 by using a coupon, but now we're in the y equals mx plus b. We have still that initial cost. We're still have to pay something. You can't walk out with, not having paid anything. So that's not going to work. Now we've got two different tables. So it should theoretically work to figure out how we're going to do this with tables, but even that sometimes can be a little bit challenging. So let's look at C first. So in order to figure out what our slope is, we need to just find the difference between these two values here. Okay, so if we look at the difference here is 2, and then the difference here is going to be 1275 minus 1425. So that's going to be 8.5. All right, so if we take half of 8.5, right, since that was a slope of 2, we need to do 8.5, we need to divide by 2. That's going to be 4.25. Okay, so that could possibly work. But That means we have a unit rate of 4.25. If we take that down to 0, right, that looks like that would be 0. So how could both of these work? Well, they both can't work. Let's look at this next jump right here. So that's going to be 2. Look at this difference here. This is 22.25 minus 12.75. That's not that same jump of 8.5, I don't believe. It's going to be 0. That's going to be 5. Oh, it's 9.5. So it's not a constant rate. Not a constant rate. It looks like this is acting more like an exponential, to where it's increasing or something like that. So we can't use C because it doesn't have that same, because they're both a difference of 2 in the x. So you would expect them, if they both had that difference of 8.5 in the y, then that would have been a possible choice. Still wouldn't have made it any easier to choose between that and A. And then let's do the same thing here. I've got a difference of 3. That's a difference of 2. So my unit rate is 2/3, right? Change of y over change of x. So if I take that back 1, that 0 is still going to be 2 and 1/3. So that's not going to work. So our answer is A, but as you could probably suspect, we have a whole lot of students that are choosing C. In fact, more students chose C than chose the correct answer. So we had 30% of our students choose A. We had 35% of our students choose C. And because if you look at just this right here, it works. And if you're looking at that, you're like, oh, that's got to be it. Because if you take that unit rate of 4.25 back to the x of 0, then you would get a y of 0, which means you're going through the origin, which means you're proportional. But that unit rate does not hold up. It increases here, which means it's not going to be a linear relationship. It's going to have a slight curve, and we can't use it. And so that definitely makes this a very, very challenging problem. In fact, this is our second hardest item on the entire test, because even if you get away from that, you look at B had 17%, D had 18%. This was a lot of guessing, a few students trying to make some informed choices. This this was very tricky. This was definitely a trick because this first relationship worked here. So we have to have our students work through, when you have a table of values, you have to go through every single one of them, not just that first pair. Number 13, we are looking at dilations. This is 8.3b. And so we have two different triangles here, and we need to find a true statement describing this relationship here. All right, so we have from triangle P, R, Q, or PQR goes to P prime, Q prime, R prime. So let's look at these statements. PQR was dilated by a scale factor of 1/3. Well, let's see. Let's look at P. Let's just look at that, right? P is going to be 1, 3, right? So the idea is if we take that by the scale factor of 1/3, you can take 1/3 of that, and you should be getting your P prime, which is x of 3, y of 9. So if you take 1/3 of 1, do you get 3? If you take 1/3 of 3, do you get 9? No, that's actually reversed. So it is a 3, but if this said by scale factor of 3, you triple it is what you get. So that's not going to be correct. We have a proportion here, so PR over P prime R prime, so that's fine. But if you're going to do R prime, Q prime, and RQ, you need to reverse these, right? This would work if you had RQ over R prime, Q prime. You need the original shape across from the dilated shape, or the original side over the dilated side, and then have those both in the same position, numerator, denominator. So that's not going to work either. So this is P prime, Q prime equals triple. That's what we're looking for. If you, instead of what I did right here, if you triple it, 3 times 1 makes 3, 3 times 3 makes 9. So that is going to be our answer there. And then obviously D has to not work. It's not congruent. Now, if you wanted to say similar, then now I've got two correct answers because they are similar. Dilation keeps it similar, keeps the angles the exact same, and it keeps its sides proportional, but they're not congruent. They're not same size, same shape. Well, as you can imagine, this also was confusing for students. We had 30% of our students choose A because they saw that one third and they did see a one third relationship, but it was going the wrong way. So 30% chose A and only 31% chose C. So basically, in effect, about the same amount of people chose both of those. And so that made this extremely difficult. In fact, this was our third hardest item on the test. And so when we're trying to evaluate the difference here, I highly suggest that our students would do what I did, turn it into some like, algebraic notation there, where you're trying to multiply and trying to evaluate if I take one third of this, would that give me my new coordinates? So we need to do some basic multiplication rather than just eyeballing it and saying, yeah, it looks like it's a 3 times bigger. It was going the wrong way. That's what made A incorrect. For number 14, we are writing equations and inequalities, and we've just got to type everything out here. You notice that this is a uh, 4 different blanks. We just got to type it in. So it might as well be like we're writing on a piece of paper. There's no drop down or drag and drop for us to use as kind of a guide. So this is going to be 8.8a. And let's see what we have here. Jamia can rent a moving truck from company A for $49 plus 65 cents per mile. So there's my unit rate. 65x. Now, I don't know which side that goes on. So that's going to be either on the left side or the right side. So you can rent a moving truck from company B for 60. I'll just put it right here for now, plus 55 cents per mile. All right, so X is going to be my miles. So we need to write this inequality that represents the minimum number of miles for which the cost of renting a moving truck from company A. So company A is the first one. So I did that first. Is greater than, which they gave you the greater than. It's different than B. And so guess what they did, guys? They literally gave you the numbers in order because that's exactly what I have here. Here's my company A. Here's my company B. If they wanted company B to be greater than company A, then we would have had to flip it because that greater than symbol is just sitting there and there's nothing we can do to change that. So all we're going to do is we're going to take this and we're going to put the numbers in order. All right, so we're going to put $49 and it's just going to be 0.65. You could just put 0.65 if you want to, that'd be fine. This is going to be 60. We don't need the .00. And we could put the 0.55 or just the 0.55. That's it. That's our answer. And so we're just taking those, we put in order. Now we have 4 different blanks. It's just a 1 point problem. You either get it or you don't. You can't have a partially correct inequality. So this is 1 point only, and 58% of our students, almost 60, were able to get that. And they might have thought, can't be that easy, right? Well, in this case, it could be this easy. In fact, this was tied for our 13th easiest item on the test. And so sometimes it's just as simple as taking the numbers, putting them in there. But ways they could have easily changed this is they gave us the $49. They even gave us the constant and the unit rate in that correct order. I could easily have seen them switch those two. They could have said 65 cents per mile plus $49. And so you might have had to flip those in order to get them here because that X is locked in. As I said, they could have asked for the an inequality that shows when company B is greater than company A, and then you would have had to flip those. That would have been a much more rigorous problem, but they didn't. They just gave everything in order. For number 15, we are looking at the Pythagorean theorem on the coordinate plane. This is 8.7d. We've got this line segment, and we need to just find the measurement closest to its length. Now, this is a diagonal, And what we should not do is we should not try to just kind of estimate and say, oh, that's about 1, 2, 3, 4, and so on and so forth, because you can't get accurate measurements that way, and you're just kind of guesstimating, and then you get sections like this, and are you going to count that as 1? Are you going to count that as 2? That's not how any of that works. Something fundamental to mathematics that we really focus on in 8th grade is the Pythagorean theorem. So if we were to drop a line right here, let's make this M, and let's make it go right over there. What I've done is I've made perpendicular lines from point L and point N, therefore it's a right triangle. And so what we know is that our Pythagorean theorem says a squared plus b squared equals c squared. It doesn't give us any context, but we need to know that's a part of the right triangle. And so that means a squared plus b squared is going to be your two legs. So these are the two sides coming out of the right angle. And then the c is going to be your hypotenuse. And so if we just say LM is A and MN is B, then we can make our hypotenuse, which is always across from your right angle, C. Now, I can find the lengths because these are vertical or horizontal lines. 1, 2, 3, 4, 5, 6. All right, so A equals 6. B equals 1, 2, 3, 4, 5, 6, 7, 8, 9. B equals 9. All right, so if I plug this in, what I'm going to get is 6 squared plus 9 squared equals c squared, right? That's what the Pythagorean theorem, which has been proved so many different ways, tells us. All right, so I've got 36 plus 81 equals c squared. So I've got 117 equals c squared. Now, in order to find c, we need to take the square root of both sides, and let's go ahead and get our calculator out for that. And so I'm just going to hit the second button and then the x squared to get that blue square root, 117, and it's 10.81, which is closest to, we're rounding to the nearest whole number, 11 units. And so that is our answer D. So that's about 11 units long. This was difficult. This was tied for our sixth most difficult item, probably simply because if you're not using a right triangle, if you're not applying the Pythagorean theorem, we're just guesstimating here. We had only 34% of our students get this right. We had 32% of our students choose A, 9 units. Now, how do you get 9 units? Well, that's the difference of the x values. The 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a 7 minus negative 2. And so you had almost as many students get it right as think, well, maybe it's just the difference between, the L and N horizontally. And so we need to first recognize when we see any slanted line like this, we can turn it into a right triangle and apply the Pythagorean theorem. That's something that we focus on in 8th grade, but apparently we need a little bit more work. Number 16, we are modeling slope-intercept form. This is 8.5i. And as you can see, we've got a drag and drop 2-point problem. And so what do we have here? Well, we have a linear relationship. We've got two ordered pairs, nothing visually for us though. And we need to write a slope-intercept form that can model this relationship. So y equals blank x plus blank. Right, our slope-intercept form is y equals mx plus b. And neither of those has an x of 0, so we can't get the y-intercept immediately. All right, so we're going to need to apply two different formulas here. Let me get this right here for us. And it's a straight line. It's a linear relationship. So we're going to stay up in the linear equations here. Okay. And so what we want to do is we want to find the slope of a line. So let's start with this. All right. So if we're going to start with the slope of a line, we need 2 points, and that's what they give us. So let's label this x1, y1, x2, y2. If you reverse those, you're going to get the same answer, so no big deal. So it's m equals y sub 2 minus y sub 1 over x sub 2 over x sub 1. So that means we are going to have our our y sub 2 is 7, y sub 1 is 2, x sub 2 is 5, x sub 1 is 1. So 7 minus 2 is 5, 5 minus 1 is 4. Okay, so I've got 5/4, and I'm going to need to put that into a decimal. So this is going to be 1 and 1/4, which is 1.25. All right, so we can at least put that right there. Now I need to put this into, I need to find the b. How do I find the b? Well, the second equation is simply the slope-intercept form. We're going to use what we have here. We're going to substitute in one of the values of x and y. I suggest using that one. Numbers are smaller. Always use the easiest numbers possible. Let's plug those in. I'm going to plug in my 2 for y. I'm going to do my 1 for the x. And then I'm going to solve for b. So 2 equals 1.25 plus b. Let's just subtract 1.25 from both sides. And that's going to get us 0.75 equals b. All right, so if you wanted to plug in these numbers, you would have gotten the exact same answer. That's also going to work. So this is a 2-point problem. We had 42% of our students get both points. 21% get 1 point. So if you take half of that, you're going to get 53%. And 36% walked away with nothing. So this ended up being right in the middle of the test, slightly on the easier side, tied for our 19th easiest. This is about as basic of a setup as you can get. Here's 2 points, call it a linear relationship, write an equation. And so you're going to need to follow those 2 steps in that sequence. Take the 2 x values and the 2 y values to find the slope, and then plug either of those 2 points back into the original equation, y equals mx plus b. You're going to have the y, the m, and the x. You're just going to have to solve for b. So our students should be comfortable with that with enough practice. Number 17, we are looking at dilation representations. So this is 8.3c. Now we don't have a picture, but we do have a table with some coordinates here. And we've got the 3 vertices of triangle MNP, and then the 3 vertices of triangle M prime, N prime, P prime. So we're dilating it. And so how are we going to figure out what our scale factor is, right? So we've got this notation here to where we're going to take our x and y and we're going to do something to our x and y. We're going to multiply it by the scale factor. And the scale factor is going to be 2/5, 2.5, 6, or 1/6. And so first, if we're going to do 2/5 or 1/6, that means they're going to shrink, right? Because it's getting smaller. You're multiplying by something less than 1. And then this is an enlargement because they're multiplying by something greater than 1, right? So let's take a look at what we have here. And the negatives sometimes going to be a little bit confusing. So let's just kind of focus in on this, right? So our 2 goes to 5. So that looks like that's getting larger. Our 6 goes to 15. Now I know they're getting larger because you have to have a center of dilation, and typically in 8th grade, the origin is the center of dilation. But imagine this point going from x of 2 to an x of 5, and then a y of 6 to a y of 15. So I can at least knock that down. And you can just use your basic math. How are you going to get from 2 to 5? You're not going to multiply by 6, you're going to multiply by 2.5. Or what you can do is you can just make it a ratio of what are the prime uh, coordinates here. So let me just take the y value. Okay, so that would be 15 over 6 equals 5 over 2 equals, you see I've got 15 over 6 again. Let's do a different one. Negative 10 over negative 4 equals, I've got negative 5 over negative 2. You notice how this lines up with this, right? They all equal each other. You can always take your points on the prime and then make that the numerator. Your denominator will be the points on the original image, right? The pre-image. And what does that simplify to? That all simplifies to, well, that's the simplest form, 5 halves, which equals 2.5. That's another way to do it. So our answer here is going to be B. So either way works. We had 58% of our students choose the correct answer. So that is not that bad. 15 here. 19 chose A. And if you look at 19, you notice they just inverted it, right? They did the actual preimage as the numerator and then your dilation as the denominator, which flips it upside down, and that's not what we're looking for. So overall, this ended up being easier than harder. This was the 13th, or tied for the 13th easiest item on the test. For number 18, we are looking at linear relationships. This is 8.5C, and we have a graph. It's got 7 data points. Definitely looks like there's a relationship there. It looks like I can kind of see a line, but it's not a straight line. And so let's do this. Let's draw a trend line. How many points do I have? 1, 2, 3, 4, 5, 6, 7. So I want this, I can't have the exact same number above and below. Let me change that. So I'm thinking I want these 3 to be above, those 4 to be below, and I want to get a line that kind of goes straight in between those. That's about as close as you can get. If possible, if it's an even number, you want the same amount above and below. If not, you want it really close. So let's just now plot these 4 points. Which pair of points would be added? All right, so this first point we'll put in blue, 3, 7. Whoa, that's not going to work. And 8, 1. Okay, no thank you. Let's do black points here for 2, 1 and 2, 8. And I'll draw circles around those to kind of differentiate them. The 2, 1 isn't horrible, but that 2, 8 makes 0 sense. All right, we've already done blue, so let's do red. 2, 5 and 6, 1. So 2, 5, it's a bit high. 6, 1, it's way low. All right, so maybe it's this last one. Let's do green. 5, 4 and 6, 6. 5, 4. Now that's what I'm talking about. 6, 6. It's a tad high, but that 5, 4 definitely gives it away. And that's honestly the closest that we have. So our answer is going to be D. And that was actually pretty easy for our students. 71% of our students got that. So they most likely graphed it out and they were finding that the lines or the points that matched up with if they drew a trend line. This was pretty easy. In fact, this was the 4th easiest item on the test. So not much needed to improve there. Number 19, we are using the Pythagorean theorem. We're back with the Pythagorean theorem. We're not necessarily using it on a coordinate plane, but we are going to need the same idea. We have a right triangle, right? So I'm going to draw a right triangle. So let's see. Just going to kind of get a visual here. A leg, so that's one of the sides coming out of the angle, of the right angle. So I'll put 12 feet. Hypotenuse, that's always across from the right angle. That's the diagonal, 13.6. And then I need to find this leg right here. All right, well, remember, a squared plus b squared equals c squared. So that means I'm going to make this x. Well, we'll just keep it as a. No point changing the value there. So a squared plus my b squared is going to be 12 squared, and then I've got 13.6 squared. All right, let's get our calculator out. Let's see what we can make of this. So obviously we've got 144. I don't know what 13.6 squared is. Let's just square that. Okay, equals 184.96. And then I need to subtract the 144 from both sides and then take the square root. So let's subtract 144. All right, so I'm going to get a squared equals 40.96. And so I need to take the square root of that. So square root of 40.96, 6.4. Okay, 6.4, and that is going to be our answer. But that's how we apply the Pythagorean theorem. We know that the two legs squared equal the hypotenuse squared. So you isolate it, but you're always going to end up with something squared equals a number, and you have to take the square root of both sides. We had 59% of our students able to get this. 20% chose B, 17. Not many chose D as 5. So not much thinking went into B. Take a look at this. It is literally 12 plus 13.6. I mean, that lets us know that we've got students that have still no clue as to what to do with the Pythagorean theorem. And then this is the opposite. You take your 13.6 and you subtract 12. We're not we're not adding and we're not subtracting here. We're using the Pythagorean theorem. But that's 37% of our students that looked at that and said, I think I'm just going to add or subtract these numbers. We need some extra work with this. Even though it ended up with being on the easier side, tied for our 11th easiest. This is way too many students right here that chose those two gimme answers. Number 20, we're looking at direct variation. This is 8.5e. And so we've got Malik with a lawn mowing business. The number of lawns he mows varies directly. Okay, so does that help us with anything? Varies directly. Look at that direct variation. Y equals kx. So we could use that. Y equals kx. All right, so on Tuesday he mowed 4 lawns in 5 hours. Okay? And so what we're going to have here is we need to figure out our constant of variation, right? So k equals y over x. Okay, and then we can go ahead and just plug that in. Okay, if we can find that k. Now, what they haven't defined for us are the dependent and the independent variables. So our independent variable is going to be our x. That starts things off. Dependent variable is our y, and it depends on what we do to that x. In this case, we're multiplying it by k, if we can figure out what that is. Well, we have this right here, 4 lawns in 5 hours. So here's a trick that you need to remember. If you're getting stuck on which one is dependent, which one is independent, if there's anything to do with time, time is always going to be your independent variable. Okay? So let's make our time 5 hours and our dependent variable 4 lawns. Okay, so that's going to end up being 0.8 or 4/5. All right, so that's my constant of variation. So I'm going to say my k equals 0.8. Now, how many lawns can he mow if he works 7.5 hours? Okay, so lawns can he mow is going to be y, because that my y is the lawns that are mown. 4 lawns hours. My constant of variation 0.8, and then I'm going to multiply that by 7.5 hours. All right, so let's multiply 7.5 times 0.8. I've got 6. Okay, so equals 6. So I can mow 6 lawns. And let's see if that proportion works, because you can also use a proportion, right? You can say 4 lawns, 5 hours, putting the unit to make sure that we put the units correctly. And you can say 7.5 hours equals blank lawns, right? And you would do a little cross multiplication, and 4 times 7.5 equals 5 times whatever that blank is, right? So you have to multiply 4 times 7.5 and then divide by 5. Either way, you're going to end up getting that 6, and so that is going to work. This ends up just being 30 equals 5x, which goes back to 6. So here's our answer. Two different ways to solve it: finding the constant of proportionality, setting up a proportion like we would if we were in 7th grade. So 48% of our students were able to get this. 30% of our students chose A. That's a big chunk. So let's take a look at that. And with 30% choosing A, the trick here is they thought it was an additive relationship rather than a multiplicative relationship. Okay? So what they did is they just thought it was plus 2.5, right? So 4 lawns, I'm going to put an L right there, 5, 8, and then we're going to 7.58. So how do I get from 5 to 7.5? Well, I could add 2.5, which means maybe I can add 2.5 and get 6.5. That's not how that works, right? You don't make it an additive relationship, it's a multiplicative relationship. But this is how they got to A. So definitely we need some extra work there. Going back to 7th grade proportions and working with that, because you could have solved it that way if you needed to. This was kind of middle of the road, slightly on the harder side, tied for our 18th most difficult item on the test. Number 21, we are looking at volume 8.7a, and this simply requires using the correct formula and knowing how to apply it. We have a sphere, so I'll draw a sphere. Difficult to draw, but there's my sphere. Has a diameter, so I'm going to go across here like this. That's 6 cm. What is the volume of the sphere in cubic centimeters in terms of pi? Notice all my answers are going to have pi, so I'm not going to substitute 3.14 in for that. Well, what is our formula for the volume of a sphere? There we go. Volume equals 4/3 pi r cubed. All right, so V equals 4/3 pi r cubed, and I'm going to leave the pi alone. So probably don't even need a calculator here. So it's just going to be 4/3. I'm just going to use the commutative property, kind of put that out there because I want to get my r cubed. What is my r? Well, my diameter is 6, which means half of that is going to be my radius. That's 3. So that's 3 cubed. Now that's not 3 times 3. It's 3 times itself 3 times. So I can say 4/3 times 3 times 3 times 3 times pi, right? The reason I'm doing that is because I can go ahead and cancel out that right there. The 4/3 times 3 just equals 12 over 3, which equals 4. So the two threes cancel out, which means I've just got 4 times 3 times 3 times pi. I can do that in my head. So 4 times 3 makes 12 times 3 pi. That's going to equal 36 pi. And we don't need to get an actual estimate because we can keep the pi right there. Our answer is going to be B, 36 pi cubic centimeters. Now, 60% of our students were able to get this. We had 18% choose A, and what we did is we squared the radius. We just had one less 3. Instead of 3 times 3 times 3, because they're so used to the area being pi r squared, they just dropped this extra 3 right here because they didn't cube the radius, they squared the radius, and they ended up with that 12 pi. We had 12% choose C, 10% choose D. So this was definitely on the easier side, tied for our ninth easiest item on the test. Number 22, we are looking at one variable equations. All right, this is 8.8c. And so we need to find the measures of two angles are this, they are equal. All right, so let's think of this like a giant balance. All right, and on one side, you've got 1.8x plus 61. It didn't even matter that these are just two expressions. It doesn't even matter whether they're degrees or not. We're just looking for the value of x, right? And so on this side, you've got 3.4x minus 27. And so when we look at this balance, what that means is we can do something to one side of this equation as long as we do the same thing to the other side of the equation to keep it balanced, right? So I want to get my x's together and I want to get my constants together. And so I want to keep a positive x. So 3/4 is bigger than 1/8. So I'm going to subtract 1/8 x from both sides. So that's going to go away. And that means I'm going to go ahead and add 27 to both sides because I'm going to end up getting this on the other side. Okay, so that's going to be easy. 88 equals, now, 3/4 plus minus 1/8. I'm just going to reimagine this as 6/8, right? Make an equivalent fraction. 6/8 minus 1/8 equals 5/8. Now, how in the world do I get rid of that 5/8 and just make it x? Well, we can multiply by the reciprocal. If we multiply both sides by 8/5, once again, you have to do the same thing to both sides. See, the 8's cancel out and the 5's cancel out. I'm just stuck with x over here. Now I need to do 88 times 8/5, and it looks like they're going to give us our answer in terms of a fraction here. So we don't need to get it all the way down. And you notice we don't need sevenths. It is going to be eighths. We could do a calculator, or we can just go old school here. 64. That's going to be 64. That's 72. So 724 over 5. And they didn't necessarily. Let's see, let's make that 704. Excuse me. That 64 plus 6 is going to be 704. The reason I knew that, because 724 was not one of the answers. So you always go back and check, and you're like, oh, we did that wrong. So 704 is our answer. And you notice they don't want you to simplify it or turn it into a decimal. So there's the setup with the two angles, but we don't really need that. All we do need to know is that these are two expressions. They're equal to each other. We're solving for the x. Obviously, the challenge here is we need to subtract these two fractions, and then you're left with a 5/8 x. And so you've got to do something with that, and you have to know that you can multiply by the reciprocal to get rid of that 5/8. Only 47% of our students were able to get this. 25% chose B, 16 and 12. And on this one, what they did is instead of adding the 27 to both sides, you subtract the 27 from both sides. And so instead of the 61, so they would subtract 27, they'd still get rid of it incorrectly, but then they would take the 61 and they would minus 27 instead of adding 27. And so you would get 34 instead of the 88, and then that just changes everything. And so that's how they got that B. So this was definitely on the harder side, 15th most difficult. You can use the calculator, obviously, but it just kind of goes back to your basic algebraic rules, knowing how to solve for x, how to simplify expressions. For number 23, we are using the Pythagorean theorem. This is 8.7c, and we have 2-point drag and drop here. And it might not necessarily be evident immediately that we're dealing with a Pythagorean theorem, but we have a kite and we have two lines that intersect, and one of these lines here is a right angle. From that, we can infer that the opposite angle, the vertical angle, is also right. And then if you're looking at these straight lines, there's supplementary angles. Everything needs to be right, which means we basically have four right triangles stacked with the right angles touching, so we can use the Pythagorean theorem if needed. we are looking for the missing length V, the missing length E. So here is V, all right, and as we see, we've got one leg already known for our Pythagorean theorem. Remember, this is a squared plus b squared equals c squared, and we can go ahead and label this side length V is A, that 8 inches B, and then our C, our hypotenuse, is going to be that 10 inches. So let's deal with that first one first. So we'll say A squared plus 8 squared equals C squared, which is going to be 10 squared. So A squared equals 60, or plus 64, excuse me, equals 100. Let's subtract 64 from both sides. So I've got A squared equals 36. Take the square root, right? It could be plus or minus, but we're not going to end up with a negative, so we just need the positive root. So that's going to be A equals 6. So 6, 8, and 10, which makes sense because 3, 4, and 5 work, and you just kind of double that. So that V is going to be 6. See if that next one is just as easy. We've got key here, and we need 8 and 15. All right, so we'll make this 15 our A. We can make that 8 our B again, and then this will be our C. So 15 squared plus 8 squared equals C squared. This, let's go ahead and get our calculator out on this. And let's see what we have here. 15 squared is 225. We'll go ahead and do that just to see it. Right, and then we will plus 8 squared. What are we going to get? All right, so 289. So 289 equals C squared, and then let's take the square root of both. 289, there we go, 17. So 17 is going to be our missing side length V. And there we go. Those are our 2 points, 6 inches and 17 inches. Now, how did we do? We just had to apply the Pythagorean theorem 2 different times. Well, this ended up being on the harder side. This was tied for our 15th hardest item on the test. We only had 34% of our students get both of those correct. 25% of our students get one correct. So you put those together with that half credit, you're going to get 47%. That means a full 40% of our students didn't get any of that. So we really still need to spend a few extra moments talking about the Pythagorean theorem. It shows up so many times in 8th grade. Whenever you see just a diagonal line on a coordinate plane, whenever you see a right triangle, or sometimes now within a larger quadrilateral that can be broken up into right triangles. We need to be able to apply that Pythagorean theorem early and often. Number 24, we are looking at scientific notation. This is 8.2c, and this is, at its heart, we're looking at this 27 million degrees, and in case we didn't know how to write that, they do give it to us in standard form. We need to make that in a much more easily readable format. That's what scientific notation is, because that's just a lot of zeros when numbers get really, really large or really, really small. Counting the zeros to try to figure out what the number actually is becomes a pain. So here's the rule with scientific notation. So we have this coefficient, right? And it needs to be between, the coefficient needs to be uh, less than uh, less than 10, right? So it needs to be a one-digit number, but it needs to be greater than 0. So first off, we can get rid of these two right here because it's 27. So it needs to be less than 10, greater than 0. So we're really stuck with 2. And take a look. This negative 7 means we're going the opposite way. 2, 7 to the negative 7 means we're going left 1, 2, 3, 4, 5, 6, 7. So that's what that reads. And that is incorrect. This one is 2.7, and you go to the right 7 times. 1, 2, 3, 4, 5, 6, 7. Put your zeros in your blanks. And here we go, 27 million. So our answer here is C. Now, we had 45% only choose this. We had 44% choose this. Now, remember, I said that the coefficient has to be between 0 and 10. If you take 27, put the decimal there, and move it over 6 times, 1, 2, 3, 4, 5, 6, to match our exponent, guess what you get? You get a number that's technically correct. It is 27 million. It's wrong because the coefficient is incorrect. So you need to be paying attention to everything, not just does it make 27 million. This ended up being our 14th hardest item on the test, and it was a huge misconception about that coefficient and the limits of that coefficient, that it needed to be greater than 0 and less than 10. And between those two, we almost had, almost 90% of the students choosing that. That was a 5. So that ended up being really good, except for half of them chose the wrong one. Number 25, we are looking at the volume of a cylinder, specifically how we can describe it. This is 8.6a. All right, and so we have the diameter of the swimming pool is 15 feet. All right, so we're going to do an above ground pool. Let's do something like this. All right, so here's our visual. All right, the diameter is 15 feet, so I'm just going to do this. All right, our height is 4.5 feet, which makes sense. They're not very tall, not very deep. And then we need to find the volume. Okay, well, how do we find the volume? Let's look at our reference material. And we've got volume of a prism or cylinder is volume equals base times height, but we need 2. That big B is the area, and what is our base? Our area is a circle, so we need the area of a circle as well. So area equals pi r squared. That's the tricky part, is realizing that you basically need 2 different formulas there. Okay, so if I can substitute this into that base, basically what we're saying is pi r squared times height, because the pi r squared is the area of the base, and so I can substitute that in there. And so look, I'm going to keep pi on the outside, and I need r squared, and then I need my height. Well, what is my radius is going to be half of 15, so half of 15 is going to be 7.5, so I need 7.5 squared. So I'll put that here. And then my height was 4.5. And so there we go. That is the correct answer. Or the STAAR test will also accept if you flip those. You're going to get the same answer if you put the height first and the radius squared second. But that is a 2-point problem, one for each of those. And only 36% of our students were able to get both points. 40% got one. So they probably got stuck with that. They might have done the diameter squared. They might have done just the radius instead of the radius squared. There's quite a few different ways. They might have just done the diameter, right? I think most of our students probably got that height. But you put those together, you're looking at 56% overall correct. And 24% of our students walked away with nothing. So this definitely wasn't as challenging. It's slightly on the easier side because of that 56%. But still, we had quite a few students that left a few points on the table here. And the biggest idea here is understanding that when you do volume equals base times height, you're never done, because that big B for base is itself a different formula based on what shape the base is. And so being able to substitute in, if it's a rectangle, right, base times height. If it's triangle, 1/2 base times height. If it's a circle, right, pi r squared. You need to substitute in another formula into that base. That's the big learning here for 8th graders. 26, we are looking at calculating interest. This is 8.12D. And so we have Jack is going to deposit $500. He's going to earn 2% interest compounded annually, make no additional deposits or withdrawals, so that principal is staying the same. Now, how much more? So we actually have to compare. He will earn an interest on this account than if he would have earned a simple interest. All right, so I need to actually have both of those formulas out here. So let's get both of our reference materials out, both of our formulas, because I need to compare those two. So my simple is I equals PRT. Compound A different. You're calculating two different things here. And then you raise it to the T power. Okay, so let's write this out. And then we'll also use our calculator as well. All right, so when we're looking at the simple, let's do this first. Interest equals principal, PRT, principal times rate times time. What's my principal? 500 bucks. What's my rate? 2%. I need to make that a decimal. 0.02. 2% equals 2 per 100, so 200ths. And then what is my time? 2 years. All right, so let's figure that out. Uh, let's go back. Let's do 500 times 0.02 times 2. All right, $20 in interest. Now, here's the thing. If I'm doing my compound, it's going to actually give me the full new amount. I have to do an extra subtraction to see what the actual interest is, but we're not calculating for the interest in the compound. We're looking for the new amount. We could do it. We just have to take an extra step afterwards. So let's do this right here. So the principal, 500. 1 plus my rate, 0.02. And then I'm going to raise it to the second power. All right, so let's do this. 500. I'm going to just go ahead and do 1.02. And then I'm going to raise it. So I'm going to use uh, to the second power. I can do that x to the y, or since it is a squared, right, I can go ahead and just square it. So that works. But if it was something other than 2, you would need to do that x to the y so that you could change whatever that exponent is going to be. All right, so we've got 520 and 20 cents. Okay, so that's going to equal 520 and 20 cents. Now that's not the amount of interest. That's the new amount. What did I start with? I started with 500, which means I earned $20.20 if I compounded it rather than earning simple interest. Well, what did I make with simple interest? $20. What did I make with compound interest? $20.20. So what's the difference? I made 20 extra cents in 2 years. Not a lot of difference in the initial years. It gets a lot steeper as the years goes on, but those first few initial years, there's not much difference between compound and simple interest. So our answer here is 20 cents. And so we had only 29% of our students get this. 43%. Let's take a look at that. 43% of our students got $20. How did we get $20? Well, this is just the amount of the simple interest. So some students did the first step and they just stopped. They didn't see this compare. They didn't see that we were looking at this account refers to compounded annually. Simple interest is in the question. So if you're just looking at simple interest, then $20 is right there. So this is as much of a reading problem as it is a math problem to make sure we're making full sense of the situation. This was definitely on the harder side. This was the 20th hardest item on the test, so kind of right in the middle of a 40 item exam. For our next one, number 27, we are modeling the Pythagorean theorem. We are back to this. So we see this model here. These are the squares. All right, so when we're looking at a squared plus b squared equals c squared, we are literally saying that this square area plus this square area equals this square area. That's what we're talking about. So the area of square x is 441. The area of square y is 400. Which measurement is the closest to the side length of square z? Okay, so first off, let's add these. So 441 plus 400 is going to be 841. It's a square, so in order to find the side length, right, the area is side times side, you're going to need to end up taking the square root of 841, right? Because in order to get 841, you multiplied the side length times the side length, or you did the side squared. So 841. All right, so 29. All right, so there we go. So then our answer is going to be A, 29. And yet, take a look at our answer selections here. This visualization apparently threw a lot of students off. When you see all of these hovering around 25, this means everyone was guessing. And a big chunk of our A correct answers was also guessing. And so some students here, right? 29 was the correct answer. The other answer that had as much as that, it didn't take the square root. That's just your 841. Didn't take that square root. So when we're talking about the right triangle, we're talking about a squared plus b squared plus c squared. Do we actually know that we're dealing with squares here? And so we need students to be able to see those squares and not have them throw that off. This was the most difficult item on the test. Not only because we had such a low amount of students get it correct, because look at the incorrect answer choices. There wasn't a misconception. It was just there were few students that actually had any idea what to do with this problem. Very confusing, very challenging. Number 28, we are looking at slope as unit rate. This is 8.4b. All right, so Dylan can bike 6 miles in 0.5 hours. Which line has a slope that best represents Dylan's speed in miles per hour? All right, so if we were to do, let's solve this with a double number line here. So if we were to say that we've got our time is always our x variable there. I've got 0.5 hours, and I've got miles. I've got 6 miles, right? I want a unit rate here. So I want to get this denominator. Think of this as our fraction, right? You can see that right there. So let's just double it. Let's just make that 1. Let's make that 12. Okay, so 12 miles per hour. All right, so that's pretty easy. So if I get my x coordinates and my y coordinates right, if I'm looking at an x of 1, I should see a y of 12. I could double this again. I can get 2, and I can get 24, right? So let's just look for some of these points. 224, and if I did another set of 12, I'm going up by 1s here, and then I'm going by 12s here, that's going to be 36. All right, so I'm looking for these 3 points. So 112, that is below 12. That's like 1, 5, so that A is not going to work. Okay, that 112, that looks okay. 224, yes. 336, okay, I like B. That 1 is way too small, and we can see the 2 is too small. 2 is at 10, it should be at 24. Whoa, looks like this one is way too steep. This is 130, 260. That's a unit rate of 30 miles an hour. That's very fast. All right, our answer here is B. And let's see how we did. This one was on the easier side. We had 18% choose A. B had 55%. That's our correct answer. C, 16%. And then that last one that was way too steep was D. So really, there wasn't a distractor that was really jumping out. You either got it or you were kind of guessing. And this was the tied for our 16th easiest item on the test. And so this one was pretty straightforward. The challenge here was, trying to figure out what that unit rate would be. But you could, if you wanted to, you could just, graph that, right? 0.5 would be by here, but then you had to kind of estimate where that 6 was. So that kind of made it challenging. Number 29, we are looking at dilation representations. This is 8.3c. And we have a quadrilateral that is not drawn for us. So let's go ahead and make a quick sketch. Okay, so we can go ahead and get a coordinate plane. And so let's do that. All right, so what do we have here? It's has the origin as the center of dilation. That typically happens. Okay, so we have a quadrilateral. All we have are 2 points, right? We have point P and then point P prime. We don't know which way it's shaded. So let's just get these 2 points down here. So I'm going to get a quick sketch of 3, 6. So here's my 3, and we'll say here's my 6. It's going to be double the size. Okay, so let's say here's my point P. And then point P prime is going to be 8 and then 16. So I'll do this 8, and then honestly, I need to bring that up. 16 would be like, I'm just guessing around here, way up here. There's my P prime. Now, what is the best way to represent this dilation? Well, first off, let's get rid of 2 different answer choices. When we dilate, we are shrinking or enlarging. We are not translating. These are translations where you're just shifting the x values and the y values. That's a rigid transformation. It keeps the congruency of the shape. We don't want that. Dilation, which is what they tell us it is, shrinks it or enlarges it. So it keeps it similar with the same congruent angles, and the sides are proportional, but they're not congruent. So here's my question. Are we getting bigger or are we getting smaller? Well, P goes from 3 to 8 on the X, goes from 6 to 18. Looks like we are getting larger. So this one is greater than 1. So without even doing any type of calculation, we can say that's got to be it because this is less than 1. So that's going to be when we shrink, we do something that's less than 1. And when we enlarge it or we grow it, it's greater than 1. So it is going to be C. Now, how we get the exact 8/3 is you take your P prime over P. So if you take your Y values, you have 16 over 6, which is equal to our X values of 8 over 3, right? That simplifies and reduces. And if we had points Q, R, and T mapped out, they would all equal this simplified 8/3. So our answer there is C, but we only had 44% of our students choose this. We had 33% of our students choose A. That's the most chosen incorrect answer. And as you can see here, look what we did. Plus 5 on the X, plus 10 on the Y. They thought it was a translation. We need to know that when we are dealing with translations, those are rigid transformations. A dilation is not a rigid transformation. It grows or shrinks, which means we're not going to add or subtract. We are going to multiply. And this was, unfortunately, on the harder side. This was the 13th hardest item on the test. Probably didn't need to be, but there was that big misconception there. Next, number 30, we're looking at 8.4c. This is slope and y-intercept. And so we have Eve starting a job, and we have an hourly wage. We have a cost of her uniform taken out of her first paycheck. That's kind of standard practice, but this is going to be constant. So whenever we're reading a verbal description like this, we should be looking out for unit rates and we should be looking for constants. All right, so here's the number of hours she would work. Here's her first paycheck amount. Look, she worked 2 hours and only made $3.50. Why? Because they took her uniform cost out. Okay, so what is her hourly wage? Well, let's use our slope-intercept form. That idea of a constant should make us think of slope-intercept form y equals mx plus b. So it's going to end up being a linear equation like that. And I want to find the slope. That's going to be her hourly cost. So I can take the difference between two y values over the difference between two x values. All right, so let's figure out what that is. So it doesn't matter which ones we do. So I'm just going to make this x sub 1 and x sub 2. I just need to match up y sub 1 with x sub 1 and y sub 2 with x sub 2. Those are just the smallest numbers we have. It works with any of them. So my y sub 2 is 350. 3.5 minus 46.25. Now, it doesn't matter that that's going to end up being negative because my denominator is going to be negative. So two negatives are going to end up canceling out, making a positive. So she doesn't earn negative money. She's going to earn positive money. So let's do 3.5 minus 46.25. And that is going to be negative 42.75. We're going to divide that by negative 3. 2 minus 5 is 3. So let's divide that by negative 3. Okay, so $14.25. That makes sense. That's decent wage right there. 14.20 could be minimum wage. Every state kind of has different minimum wages. All right, so 14.25 is the hourly wage. That's the unit rate per hour. Now, what's the uniform cost? Well, let's just back this up. Okay, so let's take our 350 and let's subtract an hour, and that's going to be negative 1075. Okay, so after 1 hour of work, I took the 1425 away. We're at now 1075. So she owes money, but I don't want it for just 1 hour. I want 0 hours. I want to know what that y-intercept is going to be because y equals mx plus b. If I can get my x to be 0, that cancels out, and whatever my y is going to end up being my b. And that's what I'm looking for. So let's take away another 1425. 25 bucks. Okay, so $25 uniform, right? And it takes her 2 hours just to earn anything, but then after that, it initially gets better. So it's a $25 uniform cost. So our equation would end up, if they asked for it, would be y equals 14.25x minus 25. So our y-intercept, if we were to graph this, would be way down here. And would go like this. All right, so how did we do on number 30? This is a 2-point problem, and we had only 34% of our students get both points. We had 18% of our students, not a lot, get 1 point. So that overall percentage correct is 43. We had 48%, almost half our students have no clue. Didn't know how to take this table of values in the real world situation, find the unit cost, and then back that up to an x of 0 to figure out what that y-intercept is going to be. And this is rich in context. This is definitely quite a bit of words to read, and so students might be used to just looking at tables and doing it rather than reading it in a real world situation. And the fact that, we've got negative 1075, students might have thought that was, um, you know, that was incorrect to have negative. and then to interpret that and say, oh, that's what the uniform cost. Even if they got to negative 25, they might have thought they were reading it wrong. And so that's why understanding the context is also going to help. So this was tied for our 11th most difficult item on the test. For number 31, we are looking at trend lines. This is 8.5D, and we have a scatter plot here, and we need to make a prediction. And so I think the easiest way to do this is to use the connect line feature. So let's go ahead and change our grid size to small. And let's see what we have working here. We've got our predictions down there, and I'll just kind of leave it right there. And so what we're looking for is we're looking for about half of the points to be above and half the points to be below the trend line. So let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So let's do 9 and 9. So I want 1, 2, 3, 4, 5, 6, 7. Really, only those 7 work. I'll do these two, 8 and 9. All right, so we'll do those 9 above, and we will add a trend line. And what we want to do is we want to try to get those ones that have circled above, ones that are uncircled below. And there we go. There's a good estimate that's using the graphing tool. You have half of the dots above, half the dots below. Now, what are our predictions here? So they want us to see when x is 10, y could be 6.5. So put that right there. Y could be 10. Now that's let's do the add point here. All right, so I'm meant to do that right there, that right there. All right, we'll just ignore that line. It could be a 12.5. Okay, that's above. I can't even get that on there. Or it could be 8. And yeah, 8 is it. So that is our answer is 8. We had 61% of our students get this, which means this was not a very difficult item. We did have 21% of our students choose 10, and that's just slightly overestimating. Even graphing those, the only two that really make sense would be these two, that 10 and the 12.5 make no sense if you are looking for that linear relationship. We had 8 and 11. So this wasn't super difficult. In fact, this was tied for our 7th easiest item on the test. For number 32, we are looking at transformations on the coordinate plane. This is 8.10c. This is a 2-point problem with drag and drop. We don't have any visual here, so I'm going to draw this visual to kind of give us at least something to anchor our thinking on. We have a triangle, UVW. All right, so I'm going to make it like this so it's kind of distinct. It seems like it's pointing away. And I'll call this U, and I'll call that V, and I'll call that W. All right. Now, it's going to be reflected across the y-axis. None of these algebraic rules are available on the reference material, so we have to either use spatial reasoning, draw it out, or we have these memorized. Either one works. So if we want to reflect this across the y-axis, what that means is we're going to make everything go over here. Okay, so I'm going to kind of go like my v prime would be up here, my u prime would be here, and then my w prime would be somewhere around there. All right, so we reflected that across the y-axis. Now, what happened to my x values? Well, my x turned into a negative x, and my y, you notice I didn't shift anything up or down, so my y value stayed the same. All right, so we can see that our uh, x simply becomes negative, and our y value stays the same. And so we can do this right here. All right, and that's going to be our first one. Now, we need to rotate it clockwise. Okay, this one is a little bit trickier to draw. A lot of times when we draw, it ends up not necessarily working. So I suggest, at least for me, memorizing these clockwise and counterclockwise. Now, what I will say is that you can turn anything into a clockwise rotation because that ends up being the trick. Okay, so if I'm going to do a 90 degrees clockwise, I'm going to do this right here, 90 degrees and then I'm going to do clockwise like this. Okay, so that means it's going to rotate down like this. That is a certain rule. But if you did a 270 degrees counterclockwise, that's going to be 90, 180, and that ends up being a 90 degrees counterclockwise. So a 270-degree counterclockwise is the same as a 90 degrees clockwise. Likewise, if you wanted to do a 90 degrees counter, that's the same as a 90, 180, 270 degrees clockwise. So it might seem like, and obviously we're skipping the 180. The 180 is pretty simple. It goes negative x, negative y. It's the 90 degrees clockwise and the 90 degrees counterclockwise that tends to kind of mess us up. But if we think of those as two movements rather than four movements, because the 270-degree counter is the same as a 90 degrees clockwise and so on, then there's only two things we need to memorize. And this is how I remember it, and everyone remembers it slightly different. So when we are looking at a clock moves this way. And I always think of the second hand. The second hand moves this way, correct? All right, so when I am moving 90 degrees clockwise, either way, if we're going 90 degrees clockwise or 90 degrees counterclockwise, you're going to flip the x and the y. But since the second hand moves this way, clockwise, it's going to be our second term that becomes negative. Likewise, if we do a counterclockwise, then the x and the y flip, but that's not the way that the second moves. Therefore, it's the first one that's going to become negative. Now, that's just a mnemonic that I have kind of had to teach myself to remind myself which one becomes negative. There's a lot of different ways out there, but it is difficult to draw those 90 degrees rotations. And so most likely your best bet is going to be memorizing those and finding some type of rule or mnemonic or whatever to remember that when you're going 90 degrees clockwise, since the second hand goes clockwise, the second term becomes negative. All right, so those are our 2 points. We only had 23% of our students get both of those correct. Now we did have 39% get one correct, and I'm guessing that most of them got the reflection correct. That's easier to understand when you draw it. So if you take the half credit, you're looking at about 43% of our students getting this correct. This is definitely on the harder side. This was tied for our 11th most difficult item on the test. Anytime we deal with these rotations and we're dealing with 90 degrees clockwise, 90 degrees counterclockwise, that's going to be a challenge for students. For number 33, we are looking at identifying functions. This is 8.5G. And we have a graph of the relationship here, or this is just a relation, and it looks like a straight line. Now, is it a function? Is it not a function? Well, it is a function if every y has one x, or every x has one y, and we can draw vertical lines, and it only hits the graph once. Doesn't double back on itself. Okay, so it is a function. So we need to get rid of these two. C and D don't work. But unfortunately, we had 21% of our students choose this and 11% of our students choose this. So it is a function. Why is it a function? Because each x value corresponds to exactly one y value. That's the definition of a function. Each x leads to one y. Or each x corresponds to multiple y values. That would make it not a function, and that's not true. Each x does not have multiple y's. So our answer here is A, but this, even though it has a graph, it really comes back to, do we understand the definition of a function? And that's only 47% of our students that got this. You notice that 21% chose this because this one, even though this part is false, this part is true. Each x value corresponds to exactly one y value. So 68% of our students remember that, but some of those, about a third of those, couldn't identify that that actually makes a function. This is way harder than it needed to be. In fact, this was tied for our 15th most difficult item on the test. And so we need to give students opportunities to use words to describe functions rather than just going through your traditional mappings or sets of ordered pairs or using the vertical line test. Can they describe a function in words? Because if they can't do that, then problems like this, when they're set to where you have to select the correct answer in a sentence format, that's going to be more challenging than it needs to be. For number 34, we are looking at comparing simple interest. This is 8.12a, and we have an inline choice, and so this is a 2-point problem. So we want to borrow this amount of money, $6,850, and we've got simple interest. Okay, how much less interest will he pay between these two? All right, so let's go ahead and get our formula here. Our reference materials let us know that when we're dealing with simple interest, and it does say simple interest right there, simple interest. So let's make sure we've underlined simple, not compound. I equals PRT. I equals PRT. And we are going to need our calculator out for this. So we'll get that out and ready. All right, so we've got bank X. I'm just going to put X. The interest at bank X is going to be the principal, 6850, times the rate. Now, the rate is 3.5%, but I need to turn that into a decimal. So this is 3.5 per 100, or 0.035, right? You can move the decimal over twice if you need to, but we need to get that decimal in the right spot or everything gets messed up. And then we're doing this for 5 years. All right, so that's bank X. Let's go ahead and calculate that. 6850. We're going to multiply that by 0.035. Multiply that by 5 years. What do we have? All right, $1,198.75. That's quite a bit of interest for 5 years. Let's check out bank Y. All right, so same principle, 6850. It's going to be 3 years, but our rate is much higher, but it's less years. All right, so this is 4.75 per 100. Move that over twice, right? So this is going to be 0.0475 times 3. Let's try that. 6850 times, let's do 3, and then I'll just use that. I want to put 0.0475. We can use the commutator property and rearrange the factors. All right, 976. So it's higher interest rate, but it's less time, two years less. Okay. So let's go ahead and subtract these two. So 1198.75 minus 976.125. We're going to have to round that because we're going to go to just the cents part. It's going to equal 222.63. We want to round that up. All right, so less interest will be paid at bank Y, and he will pay how much less interest? What did I say? 222.63. So let's do 222.63. All right, so that is how we get full credit on this. And we only had 37% of our students get full credit on that. 32% get 1. And if we put that half credit in there, we had 53% overall accuracy on this one. This is pretty straightforward. We're dealing with just simple interest, and that's what the simple interest formula calculates. It doesn't ask you for the new balance, so we're not having to add this to the principal to figure it out. So it is pretty straightforward, but you saw a lot of calculation, a lot of keeping track of numbers. And so this is just kind of a brute force approach. And so unless students are comfortable doing a lot of calculations and jotting things down, the numbers are going to get lost, and it's going to be a little bit easier in their mind to just kind of guesstimate it, especially because in that first drop down, you only have 2 choices. So they might think, oh, I've got a 50-50 chance of getting it right if they just wanted to guesstimate it. Obviously, we want them to use all of the tools to be able to use this. So this is definitely a calculator tool, and we need to be able to jot everything down. And I think one challenging fact might be that our interest rates are decimals, especially this one, right? The challenge might be turning this into this, right? They might turn that into 4.75% or 4.75% or something. Knowing that you need to turn this into 0.0475, I think that's really the challenge. And so when we're working with students, let's make sure that we have interest rates that have at least one or two decimal places to increase our practice. For 35, we're looking at volume. This is 8.7a. And it's a little bit interesting because it asks us to find the diameter, and that gives us the volume. All right, so we're dealing with a cone. So let's look at what we have with a cone. When we're dealing with our cones, we are going to see our volume is same as a pyramid, 1/3 BH. All right, so volume equals 1/3 BH. This big B always stands for something. The base of a cone is a circle, so we need to know that this is 1/3, and then I'm going to put that right there, pi r squared. We have to be able to take that base and convert it into the formula for area of something. All right, and now let's plug in what we have. They know that we've got the volume, so the volume equals approximately 1647. 1/3 is 1/3. Pi is pi. I don't know the radius, but I do know the height. So look at this. I need to do all of this. This is going to be very interesting. All right, definitely need to get our calculator out on this. I want to go ahead and simplify as much of this right-hand side as I can. So 1647 equals, I want to do 1/3. I want to multiply that by pi, and then I want to multiply that by 13. Okay, so what I'm going to do is I'm going to take care of this, this, and this. And what do I have? Okay, so 13.61 approximately. What I haven't touched is the r squared. All right, so now let's divide both sides by 13.61. So let's do 1647 divided by 13.61. All right, so 121.01. I'm just going to call that 121 because we're estimating here. So 121 equals r squared. Now, I need to take the square root of both. Now, 121 is a perfect square. If you don't remember it, right, we can plug it in, but it is 11. So my radius equals 11. If you do all of that work and select 11, you are incorrect. It is asking for the diameter. So if my radius is 11, remember the diameter is 2 radii put together. So that means your diameter equals 22. So our answer here is 22. Now that took a lot of algebraic reasoning. And if you got 13.61 r squared, students were probably thinking, I think I did something wrong. But actually, they did something right. We only had 32% of our students get the correct answer here. We had 23% of our students choose B, which I would expected that to be a little bit more because 34% of our students actually chose C. Now, what this is that they chose the volume of a cylinder. They did all this work and they just did the cylinder rather than the cone, and they didn't include the 1/3. But they did all of that work and they didn't include that 1/3. So they possibly chose the wrong formula to begin with. This was challenging. Anytime you're dealing with volume and they give you the volume and they want you to find one of the other dimensions, whether it be height or something, that makes it a little bit more challenging than just giving you all the measurements and you just multiply them. Now, in this case, they wanted you to find the diameter. So you had to get all the way down to 1647 equals 13.61 r squared. You had to divide by 13.61, take the square root, and then you had to double it to get the diameter. That is a lot of moves. And our students definitely need a lot of practice with that. That's probably the most complex you can get when you deal with a circle, and you deal with area because they're always going to use the radius. And if you ask for the diameter, that always adds that one final move at the end. Number 36, we are dealing with proportional and non-proportional graphs. This is 8.5F. And so we have a statement here, and we simply need to know, is it proportional or non-proportional? Well, this comes back to the definition of proportionality. Proportional graphs go through the origin. Doesn't matter what the slope is. Non-proportional graphs do not go through the origin. So I'll go like this, or I'll go like this, right? Non-proportional. So knowing that this is in slope-intercept form, this is y equals mx plus b. The fact that we have a plus b, in this case negative 0.5, means it's going to come down here. That means it is non-proportional. So we can do that without even graphing anything. We should be able to recognize if there is a y-intercept that's not 0, right? If it were proportional, it would look like this, y equals kx, because this plus b is gone. So this is non-proportional, and why is it non-proportional? Because the slope is a fraction, and it makes no difference at all. It's non-proportional because, and it goes to right here, because this is a solution, because it goes through 0, negative 0.5, rather than 0, 0. So this comes down to a definition, just like the problem a few problems ago about what is the definition of a function. Do we know what is the definition of a proportional graph or a proportional equation? So our answer here is A, and yet only 41% of our students were able to get this. 27% of our students chose D, and they thought because it had a constant slope of 1/2, so that fraction really kind of threw them off. 17% chose B, 14% chose C. So when we're dealing with different things in 8th grade, sometimes we tend to focus on solving equations, but we really need to take a look at the standards themselves, because this particular standard asks students to describe. Take a look at our answer choices. We're not calculating anything, we're describing with words. So if the TEKS includes the words describe, we need to have students focus on the definitions and using words to describe things like, is it a function, like the previous problem, or is it a proportional relationship? Because they're not going to be asked to calculate. They're going to be asked to select the correct answer with words. And if we focus just on the calculations, we're going to miss this opportunity to teach them the definitions of these major concepts. And this ended up being a lot harder than it needs to be. This was tied for the 9th hardest item on the test. And for number 37, we are looking at surface area. This is 8.7b. And we always need to be taking a look at, do they want the total or the lateral surface area? In this case, we need the total surface area. There is a formula that we can use. And so let's open up our reference materials. Surface area, this is a prism. And total surface area is PH plus 2B. Now, if we don't know what that means, it's not going to be very helpful. Plus 2B. All right, so this is just the lateral surface area. Perimeter times the height. So what we want to do is we want to find the perimeter of one of the bases, multiply it by the height, and then we need to find the area of the two bases. That gives us the total surface area. So lateral just does the 4 rectangles connecting the two bases. The total surface area gets those two bases involved. So let's get our calculator open. So what is my perimeter? Well, my perimeter, it's a square. Okay, so I've got 12, 12, 12, 12. So it's going to be 48, right? That's my perimeter. My height is 24. It's not lying on one of the bases, but this 24 is what connects the two bases. You're looking for what connects the two bases. So I have my perimeter of 48 because it's 12, 12, 12, 12. I've got a height of 24, and then I want to double the base. Okay, so what is the base? The area of the base is side times side, so that's 144. All right, so we can go ahead and plug all of that in. Let's do 48 times 24 plus 2, and then we're going to use the order of operations is going to make sure that we do the multiplication before we do anything else. And there we go, 1440. So if we know what our formula is and how to plug it in, pretty straightforward answer. And so we're going to do 1440 as our answer. Now, we only had 48% of our students get this correct. We had 20% of our students choose C, and this is just the lateral surface area. They didn't include the two bases, so they used the wrong formula. And then we had some calculation mistakes there. You get 16 to 17%. This ended up being a little bit more difficult than it probably needed to be. This was tied for our 18th most difficult item on the test, but take a look at the formula. This is probably one of the most involved formula because this perimeter is something that you had to figure out either in your head or you had to use another formula to do that. And then same with this base, right? Anytime you get these capitals, it's letting you know there's another formula you need to insert there. I just did the 12, 12, 12, 12 to make 48, but really this is 4 times the side, and this is the side squared, right? So you need to know what your other formulas are that need to go into those capital letters to make it actually work. 38, we are dealing with ordering numbers, and we need to find the values from least to greatest. This is 8.2D. And so let's just draw a number line here, and let's just put our numbers on here, and let's go ahead and open up our calculator. So I'm just going to put 7.42. That's the easiest one right there. Just going to kind of put that in the middle. We'll put everything else. I'm just going to use this first one here. So 38 divided by 5 is going to be 7.6. So that's going to be a little bit more. Square root of 61 is 7.8. Okay, so let me put my actual 38 fifths. This is 7.81, and that's the square root of 61. And I've got my 745%. This is move the decimal over twice. I don't need the calculator. That's 7.45. 7.45 or 745%. All right, so I'm looking for 7.42 first. 745. There we go. All right, D is our correct answer. And if we're using the calculator, it doesn't take that long. 66% of our students were able to get this. So not that much of a challenge. In fact, this was the 6th easiest item on the test, and this is where we definitely need to use the calculator to our full advantage. 39, we are dealing with congruence and transformations. This is 8.10b, and we are just dealing with the definition here. So we are transforming this quadrilateral to form the new quadrilateral, JKLM prime. Which one does not preserve congruence? Okay, so 3 of these will preserve congruence. All right, so if we reflect it over the x-axis, if I'm going to do like this, let's say this is my quadrilateral. All right, so if I do this right here, I'm reflecting it over the x-axis, so I'm flipping it, but it does preserve congruence. Reflect it over the y-axis. I'm flipping it this way. It does preserve congruence. You're taking the exact same shape and you're simply flipping it. A dilation with a scale factor. Ooh, look at that. When you scale something up, assuming that it's going to go off the chart like that. That does not preserve congruence. The angles are congruent, but the sides are proportional. And then you have a clockwise rotation, right? You would go like this, and it would kind of look like this. That preserves congruence. So we need to know that reflection, rotation, and transformation are translation are all rigid transformations. A dilation is not a rigid transformation. It scales up or scales down. So that is the one that does not preserve congruence. How did we do on this one? Well, we had 60% of our students recognize that, and simply it's a recognition and definition, so that's pretty good. This ended up being the ninth easiest, or tied for the ninth easiest item on the test, and it just goes back to recognition of the different types of transformations. We typically tend to teach these three together, but sometimes students don't know that a dilation is also a transformation. It's just a different type of transformation. And our final problem on the test is number 40, 8.5i, modeling slope-intercept form. And so we have this verbal description, and we need to turn it into this slope-intercept form here. So we're taking words and we're trying to put them into y equals mx plus b. So if we recognize all of these answers as y equals mx plus b, then let's define these terms. This is our slope, or we can also think of it as our rate of change. Now this is our y-intercept, b, but we can also think of it in real world terms, it's the starting or the initial value. And that, if we know those synonyms, the rate of change and the initial value, that's going to help us here. So the total cost for a company to make a product includes a fixed cost of $3,050 and plus 1525 per product. You see that per product? That lets you know that's your rate of change. Okay? So we're looking for C equals 1525 per product plus that fixed cost. This is a constant. And so that means it's not changing no matter how many products you have. You make one product, you make 1,000 products. You're still paying the 3,050. That is the definition of a starting value of a y-intercept. So if we do this, and then P is going to be our independent variable, we have this, and our answer is going to be D. And we did fairly well on this. We had 59% of our students get this. We had 25% of our students get this, and we just had students change the values for the slope and the y-intercept. And then we had 10 and 7, and that 200 comes from, I don't know where the 200 comes from. Maybe it's 3,050 divided by 1525. You don't need to do that. You're just taking words, putting them into slope-intercept form, and this ended up being tied for our 11th easiest item on the test.